When it comes to electric vehicles, the choices people can buy go far beyond those powered by batteries alone. These days, they can find all types, including options that rely on fuel cells or combine a gas engine in hybrid and plug-in hybrids. There are 4 main types of electric cars are available in today's market, and those are battery electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle, and fuel cell electric vehicle. So today, in this video, we are taking a look at each type and learn how these electric vehicle works, starting with the battery electric vehicles. But first, if you haven't watched my video on how an electric vehicle works, then you can watch it by clicking on the I button. Battery electric vehicles are also known as all-electric vehicles. Instead of gasoline, these vehicles run solely on battery power. The electricity used to drive the car is stored in a large battery pack which can be charged by plugging it into the electricity grid. Also, drivers can charge them at home using level 1 or level 2 EV chargers, or use more powerful chargers, level 3, designed for commercial charging stations. The charged battery pack then provides power to one or more electric motors to run the electric car. Because pure EVs typically run on battery power without an internal combustion engine's assistance, they can run much farther on a single charge than hybrid vehicles. The main components of the battery electric vehicles are electric motor, inverter, battery, and control module. The working of the battery electric vehicle is pretty simple. The power for the electric motor is converted from the DC battery to AC. As the accelerator is pressed, a signal is sent to the controller. The controller adjusts the vehicle's speed by changing the frequency of the AC power from the inverter to the motor. The motor then connects and leads to wheels turning through a cog. If the brakes are pressed, or the electric car decelerates, the motor becomes an alternator and produces power that has been sent back to the battery. Advantages of battery electric vehicles are their simple construction, operation, and convenience. They do not produce any greenhouse gas, and do not create any noise and are beneficial to the environment. Electric propulsion provides instant and high torques, even at low speeds. These vehicles are energy efficient, converting 80% of their energy input into moving the car. In contrast, gas-powered vehicles are only about 20% energy efficient. The remaining 80% of the energy input is wasted in tailpipe emissions and heat. Recharging an electric vehicle is easy, and the best part is that you no longer need to run to the fuel station to recharge your car. A regular household socket can be used to charge an electric vehicle. The features of battery electric vehicles are no emissions, not dependent on oil, cost-effective, low maintenance, reduced noise pollution, and easy driving. The problems with these vehicles are recharging points, short driving range and speed, longer recharge time, and high price. Tesla Model 3, Renault Zoe, Volkswagen e-Golf, MG ZS, Tata Nexon, and Nissan Leaf are the examples of battery electric vehicle. Hybrid electric vehicle. These are also known as a series hybrid, parallel hybrid, or series parallel based on power distribution. Hybrid electric vehicle have both engine and electric motor. The engine gets energy from fuel, and the motor receives electricity from the batteries. The transmission is rotated simultaneously by the engine and electric motor which drives the wheels. This combination helps increase the efficiency of the engine. The power distribution allows vehicles to achieve optimum power under most driving conditions. A hybrid electric vehicle cannot be plugged in to charge the battery. Instead, the battery is charged by regenerative braking and internal combustion engines, and unlike most electric cars, hybrid electric vehicles charge their batteries through regenerative braking. Regenerative braking stores the kinetic energy used to stop the car from charging its battery and help the IC engine accelerate the vehicle. One type of hybrid electric vehicle, the micro or mild hybrid, uses a battery and electric motor to make the car run. Although they can't run solely on electric power, they maximize fuel economy by shutting off the IC engine during complete stops. The full hybrid has the battery power to make the car move using electricity alone, but usually only for short distances. The 3 types of hybrid electric vehicles. Series hybrid. In this, the internal combustion engine drives an electric generator and not the wheels. The generator not only charges the battery, it also powers the motor that propels the vehicle. This setup is also known as a range-extended electric vehicle, since the IC engine powers the battery and motor but never directly drives the wheels. Parallel hybrid. Here, both an IC engine and an electric motor propel the wheels, both work in tandem and deliver optimum power output. The batteries in the vehicle charge when the motor works as a generator. These vehicles cannot drive standalone in pure electric mode. Series parallel. These vehicles use both the IC engine and the motor, working alone or in tandem. Power distribution helps the vehicle operate within its optimum range as much as possible, giving it high efficiency. Main components of hybrid electric vehicle: engine, electric motor, battery pack with controller and inverter, fuel tank, and power electronics. The working of hybrid electric vehicle is that the fuel tank supplies energy to the engine like a regular car, and the batteries run on an electric motor. Both the engine and electric motor can turn the transmission simultaneously. It is a tremendous advantage in low-speed conditions like urban areas. It also reduces fuel consumption, as the engine stays off during idling periods, such as in traffic jams. This feature also reduces GHG emissions. When a higher speed is needed, the hybrid vehicle switches to the IC engine. The two drivetrains can also work together to improve their performance. Hybrid power systems are used extensively to remove turbo lag in turbocharged cars, like the Acura NSX. The IC engine can charge up the batteries, and hybrid electric vehicles can also retrieve energy using regenerative braking. Therefore, hybrid vehicles are primarily IC engine-driven cars that use an electric drivetrain to improve mileage or performance enhancement. The features of hybrid electric vehicles are: environmentally friendly, regenerative braking system, assistance from electric motor, smaller engines, and higher resale value. And the problems of these vehicles are: less power, it can be expensive, poor handling, and battery replacement is costly. Renault Captur, Toyota Corolla, Toyota Prius, Skoda Octavia IV, BMW X545e, Mercedes E300, and Kia Niro are the examples of hybrid electric vehicle. Plug-in hybrid electric vehicle. The plug-in hybrid electric vehicles are also called series hybrids. Plug-in hybrid vehicles expand on the concept of the standard hybrid vehicle. They have both an IC engine and a battery-powered electric motor. This allows the battery to store enough power to feed the electric motor and, in turn, decrease your gas usage by as much as 60%. This can save you time and money at the gas pump. Plug-in hybrids can travel up to 40 miles on electric power alone, rather than a couple of miles with a standard hybrid vehicle. These vehicles can run in at least two modes. First, in all-electric mode, in which the motor and battery provide all the car's energy. And second, in hybrid mode, in which both electricity and petrol or diesel are employed. Main components of plug-in hybrid vehicles: electric motor, engine, battery, power electronics, fuel tank, and charger if on-board model. The working of a plug-in hybrid electric vehicle is that these vehicles start up in all-electric mode and use electricity until their battery pack is depleted. Once the battery gets drained, the engine takes over and the vehicle operates as a conventional non-plug-in hybrid. Plug-in hybrids can be charged by plugging into an outside electric power source or by engine or by regenerative braking. When brakes are applied, the electric motor acts as a generator, using the energy to charge the battery. The electric motor supplements the engine's power. As a result, smaller engines can be used, increasing the car's fuel efficiency without compromising performance. Plug-in hybrid vehicles also have the facility to utilize regenerative braking. They have the ability to run solely on electricity, most of the time, makes their carbon footprint smaller than that hybrid electric vehicles. They consume less fuel as well, and thus reduce the associated cost. The vehicle market is now quite